All right then, and now we come to our final electron configuration on our class example problems. If you're having any questions on any of this, please don't hesitate to ask. When you actually get to the homework, please be sure when you start the homework problems, when we get to 4-12 and you're doing these electron configurations, do one, then check the answer key. And if you have trouble, watch the help video. Don't just try to do all the homework and then check it. If you're doing all the homework and then checking it, you could potentially repeat the same mistake over and over and over. So if you're making mistakes, there's help videos on the 4-12 homework assignment already posted for you to watch to clear up misunderstandings. Again, do one, check the key, watch the video. Now, let's talk about how to do the anions, a negative ion. Remember, an has a negative letter right in it. An means not. So these are the ones that have extra electrons. These are negative ions. And we want to do the fluoride ion. So first we have to find fluorine on our periodic table of elements. Here's fluorine, number 9. I look above fluorine. It's S2P5. So when I'm done with fluorine, it should have 2, 5. It should have S2P5. Which S2? Here's fluorine. I go down. This is the row it's on. So it would be 2S2, 2P5 for fluorine's S2P5. Remember, fluorine is the neutral atom. When atoms gain electrons and become anions, we change the endings of the name. So fluorine goes to fluoride. We did bismuth earlier, bismuth 3 plus, where it lost the 3 electrons out of the P. We would not call it bismuthide or bismuthide. For the positive ions, they get to keep their name, and we just put ion on the end. So Bi3 plus is called the bismuth ion. The bismuth atom neutral is just called bismuth. So back to the fluoride ion. It should end in, as we said, 2s2, 2p5. So I'm going to come right back here, and I'm just going to type what it should end in right now so that I know when I get there if I've done it correct. So I have fluoride's 2s2, or fluorine. We're doing fluorine first, and then we will make it fluoride by adding an electron. Negative means there's one more minus than all the positives. Protons, 9 protons when we're done. If it has 9 positives, it starts with 9 negatives, but when it's a negative, it means now there's 10 negatives. There's one more negative than positive. That's what negative symbol means there. All right. So we're going to do the fluorine atom first and then add an electron to it. So let's head back to our periodic table of elements, and I have to backfill. I've already got all of this accounted for. So now I have to jump up. I'm going to the 9th spot, atomic number 9. So I start at square one. Hydrogen and helium are 1s2. So I'm going to come right back in here and type in the 1s2. There wasn't a very large kernel on this thing because the 1s2, after 1s2, we come back to fill in the rest. I'm trying to get to fluorine number 9, and I just want to make sure my 2s2, 2p5 that I started off with is right. So I'm going to fluorine number 9. I've already got 1 and 2 accounted for. So now I go to 3 and 4. That's the 2s, and there's 2 elements there. So that is what I should see, 2s2. I do. And now I'm going to count for the remaining parts of this. I go back. There's fluorine. It is 1, 2, 3, 4, fifth one over in the 2p. So the 2p5 is correct. How many valence electrons does fluorine have? Valence electrons are electrons in the outermost energy level number, my biggest energy level number. There's a 2, and there's a 2. So my valence electrons are in these sublevels. The 2s, there's 2. The 2p, there's 5. 2 and 5 is 7. So this thing has 7 valence electrons, which means there should be a Roman 7 above it, since fluorine is in the main block. There's fluorine, there's the Roman 7. Remember, these are offset because the main block families are the families where this number lines right up with them. And if this number lines right up with them, then it's telling you how many valence electrons they have. These numbers, once again, are not telling you how many valence electrons they are. The D block is not in the main block of the periodic table. So what is this S2D1 telling you? 2 and 1's 3. These Roman numerals are telling you how many are in the S and the D. They can't be telling you how many in the P because they haven't started filling their outermost P yet. So 2 and 1 is 3, 2 and 2 is 4, 2 and 3 is 5, 1 and 5 is 6. Why isn't this S2D4? Well, that's something that you can look up on your own. We don't really discuss it too much at this point in the chemistry year. S2D5, 2 and 5 add up to 7. 2 and 6 add up to 8. Why do they keep Roman 8s here? Because cobalt and nickel, instead of putting Roman 9, Roman 10 there, they feel it's more important to put an 8 and 8 here to tell you that cobalt and nickel behave the same as iron. Then the Roman numerals go back to 1. Why? Take a look. D10, D10. The D only holds 10. So once the D is full, they go back to telling you how many are in the S. S1, there's 1. S2, there's 2. So we know we have fluorine's configuration right. We know why there's an S2P5 above fluorine. We know how many valence electrons fluorine has. Now we have to go about the business of adding a valence electron to it. Where will it go? The only place that is open. The S2 is already closed. The only place that is open is right here. So we are going to put the electron right there. That is where the extra electron went. And now fluorine became fluoride. It now has 10 electrons. It's isoelectric. Isoelectric means it has the same electron configuration as one of our noble gases. If we give fluorine one and make it fluoride, it has 10, just like neon. If sodium lost one and ended up with 10, if it lost its 3s, it would be left with its inside octet full. It would be isoelectric to neon. If magnesium lost 2, it would be isoelectric to neon. If aluminum lost 3, it would be the same as neon. Iso means same. Electric means same electron configuration. Aluminum would be stable octet. If it lost its 1 out of the P and 2 out of the S, its inner S and P would be full with 8, satisfying the octet rule. We know why that Roman 7 is above fluorine, because fluorine started with 7 valence electrons. This explains the fluoride ion. Once again, you should hopefully be ready now to start your homework. Please check the answer key after you do each one of these. After you do a problem, check the answer key so you can learn as you go. You can clear up any confusion that you might be having as you go. Good luck. Remember, this is the easiest periodic table to use. The off-file order of filling is a very fast and easy way to learn and get comfortable with the orders that the levels are filled. In our next section, as we advance on, you will be watching a preview. So when we get to, there's a preview video tonight to watch as well. It'll be 4-13, which will take us through how to speed up doing these electron configurations and orbital notations. They're going to teach some additional shortcuts, and 4-13 will take you through those. In our next notes, we will do some practicing with those shortcuts. As always, if you have any questions, don't hesitate to contact me to ask.